chapter 16. This is going to be on thermodynamics, yes? Thermodynamics. Now, we will probably have a test on our chapter 16, our quiz, after the midterm, because I can't ask all the questions on the midterm. I can only ask 5 questions and that's it. Okay? And I made 5 questions because I want to make it easy for me to grade. So if I only do 24, then that doesn't go in 100. There's 25, now it's every one is worth 4 points. So here's the first thing. You need to define some terms. What does it mean to be adiabatic? Define the terms. Adiabatic. What does adiabatic mean?
No heat is transferred to the system or surroundings or something like that.
It's like no heat goes out of the system.
That's correct. So you can just put it with no heat, just say Q equals 0. No heat. No heat leaves or enters. Okay? Now we go to the next definition. Each one of these definitions worth 1 point. What does it mean to be isothermal? What's the definition of isothermal? What is
no heat, no like.
Isothermal. What does that mean?
Only heat is transferred? Or
No, what does it mean? Isothermal, Jarvis? What's isothermal mean? You had chemistry too. Isothermal.
It's isolated?
It's isolated.
No, isolated, that's adiabatic. What is isothermal?
Or there is
You
heat.
guys are looking away like, don't call on me.
Don't make eye contact, don't.
I can see them, they're all going like, oh my God. Andrew's all like, oh my gosh. Okay, you guys, isothermal means temperature doesn't change. No, you did not say temperature doesn't change.
Yeah, I know.
Temperature does not change.
No.
Yes.
Okay?
I can say that I haven't taken chemistry, so you cannot blame me.
That's right, that's why I didn't pick
Nope, we're blaming you.
Okay, now we have, the next one is isochoric.
All these words.
What does that mean?
Oh, dang.
Temperature does change.
No, well, it's something.
It might, but what is isochoric?
Yeah, but what doesn't
mean?
change? It's
And
something
this
that
doesn't
doesn't
mean,
change.
that doesn't mean your choir sings the same note.
I
The work.
Isochoric, what does it mean? No change in
Enthalpy?
volume.
Oh.
Oops.
Well, W is 0, because you do work, there's no, if it's isochoric, then work is 0. Work will be 0.
Okay.
Work equals 0. And then you should have on this one, delta U, or delta E equals 0. Equals 0. Right? So we have that, this is Q is 0. What is isobaric?
Oh, these isos.
What's that mean?
Pressure.
Yes, pressure. No change in pressure. So each one of these is worth 1 point. So when you get to this problem, there's part A, B, C, D. You need to go and just look them up. You just go up, isothermal. Temperature doesn't change, volume doesn't change, pressure doesn't change, no heat change. Yes? So adiabatic, isothermal, isochoric, isobaric. Yes? Not too hard to do.
That's one problem.
Yes, 1 point each.
I thought it was 4 problems, and I
Oh
was
no,
like,
then you only have one left, and then you go, but that's what I didn't do that. You're not gonna get a full point problem for no work, right? Okay, now let's go to another thing. We need to know how to calculate the pressure
No.
the work at constant pressure. So the work at constant pressure this is real simple formula. It's P times delta V. So all I have to do is take the change in volume and then multiply times the pressure, and you have the work in joules. Yeah? Real simple problem. Yes?
Pad.
Pad. Not pad.
Do we understand how to do this type of problem?
Mm-hmm.
Real simple. Okay? Also in this chapter, we learned that the area under the curve is also the work. So if I give you a process that goes like this,
Oh, yeah.
let's say it goes down like this, but then it goes up like this, and then goes across like this, so you have step 1, step 2, step 3, and then step 4, right? Like that, so you're gonna go like you have 4 steps, this is step 3, okay? Then I'm going to ask you the work at each step. So if you look here, how much work did this guy do right here in this little step? From step 1, moving from here to here. It's the area under the curve, right? So if you drew yourself in a color right here, that should make a rectangle, right? So area of a rectangle is length times width. So if I told you this was 5 and this thing here was 2, then the answer would be 2 times 5, so that's 10 joules, yeah? Because the area equals to the work, so the work's gonna be 10 joules, yeah? But now let's look at this one right here, look at step number 2. Step number 2 is a straight down line.
So it's still 10. Oh, wait, no.
It's
Zero,
It's
right?
0, there's no volume under the curve, so 0. Make sure you get the straight down lines are
Oh,
0.
but
Very
total
good.
is still 10 though. Right.
Up to that point is still
That's
10, but
how
I'm
much
gonna do it at each step. How much is at each step? So this step here, this one's doing 0. Okay, when we get to this one, what's that?
A trapezoid?
That's a trapezoid, so the area of the trapezoid is 1/2 base 1 plus base 2, put this in parentheses, times the height. Well, we already know this is 2, so let's just make it simple, that's 1, and let's make this another 5. Well then, for 10 over here, so it's gonna be 1/2, here's your base 1. Base 1 is 1, yeah? And then, what's this base? That's 2, right? Now the tricky part is what's the height? It's 10 minus 5, which is 5, right? So this is gonna be 5. So then we're gonna get 15/2 is going to be your answer, yeah?
Yep.
Because that's now gonna be the work here. And then when we go back to the work on number 4, that's just another rectangle, so I won't worry about doing that. But I just drew it to complete the drawing. But you have to do them by individual steps. Everybody understand that? You look at the steps, you go, here's a step, here's the step here, and here's the step there, like that.